In this video, we're going to be solving a non-linear application equation problem. So in our example, we have that an athletic booster club of a university chartered a bus for an away football game at a cost of $960. To lower the bus fare per person, the club invited non-members to go along. And after 5 non-members joined the trip, the fare per person decreased by $9.60. How many club members are going on the trip? Well, to think of this, we need to think of what is the cost per person, and that's going to be multiplied by the number of people. And that should give us the cost of the trip. So let's see if we can find that information in our problem. So we know that the cost of the trip is $960. What about the number of people? Well, we know that there are members of the booster club. We just don't know how many, so we're going to call that X. And we know that they invited 5 non-members to join them. So the total people are going to be the booster club members plus those 5 people. Well, what about the cost per person? Well, we know that originally they had the $960 split between all of the members, right? But then when they added those 5 people, the cost decreased by $9.60. So that $9.60 decrease, right, that's how we know it was a minus, affected our total cost from the original cost. And so our cost per person is going to be that amount. So let's go ahead and let's plug in the things that we know. So we know that we have a cost per person of 960 divided by X minus $9.60, and that we're going to be multiplying that with the number of people, which is X plus 5, and that that's going to equal the cost of our trip, which is $960. And so there's a couple different ways that we might do this problem. We're going to start off by distributing or foiling. So we're going to take our 960 over X times X, and that's going to give us 960 because the X's will cancel out. Then we're going to take our 960 divided by X and multiply that by 5. And so if we take 960 and we multiply that by 5, that's going to give us 4,800. So we have a positive 4,800 over X. Then we'll take our negative 960 times X, and that gives us a negative 960 times X. Then we'll multiply that negative 960 times 5, and that's going to give us a minus 48, and that's still all set equal to the 960. So now we're going to go ahead and combine our like terms, which looks like that might be kind of a problem. So let's try and get rid of some stuff first. So let's subtract our 960 from both sides, and I'm doing that instead of combining it with the 48 because I see that I have a 960 over here, and those will cancel out. And that's going to leave me with 4,800 over X minus 960X minus 48 equals 0. Then I'll add the 48 to both sides, and that in turn is going to give me 4,800 over X minus 960X equals 48. And from here, I can see that both of these pieces have an X in them that I can try and factor out. But because I have the X in the denominator, that could be tricky. So an idea would be to get common denominators. So if I take that 4,800 over X, subtract that with 960X, that's over 1, equals 48 over 1. So I know that this second equation needs an X, And that so does my other side of the equal sign. And that is going to give me 4,800 over x minus 960x squared over x equals 48x over x. And then by rule, because my denominators are all the same, I can go ahead and I can cancel those all out and just know that x is not allowed to equal the number 0. And then I'm going to go ahead and kind of rewrite this a little bit. And I'm going to get a, let's see, a negative 9.60x squared plus a 4,800 equals a 48x. Then we're going to move the 48x over to this side so everything's on the same side. And I'm going to have a negative 960x squared minus 48x plus 4,800 equals 0. And we're just trying to solve for x here. And so I am actually going to try something first. So I'm going to try and divide by 900, like by the $9.60, and see if I can get that to go into 48 and 4,800. And if I'm lucky, it will. So I'm going to go ahead and plug that into my calculator. And I'm going to see that that was a good strategy. That gave me an x squared, or plus rather, because a negative negative. And when I plugged in the 48 and I divided that by the negative 960, I got a 5. So I have positive 5x and then a negative 500 equals 0. I'm going to scoot it over a little bit. And now this is something that we can factor. So we're looking for two numbers that will multiply to 500 but add to a 5. Now, if you can't think of the factors, you could have always done completing the square or using the quadratic formula. But I'm going to use the numbers 25 and 20. So again, we could have factored it. We could factor it. But if we don't see what to factor, we could use the quadratic equation or completing the square. But a 25 and a negative 20 will give me a multiple of negative 500, and they'll add to 5. So I can write this in factored form as x plus 25 and x minus 20 set equal to 0. Then, using the zero product property, I can split those apart as x plus 25 equals 0 and x minus 20 equals 0, which will give me a negative 25 and a positive 20, and neither of those numbers are 0, which was part of our restriction over here, remember? And so far we're okay. So remember that x represents the Booster Club members, right? X represents our Booster Club members. So does it make sense to have negative 25 people? No, it doesn't. And so here we find that there are 20 Booster Club members. There are 20 club members on the trip. And we have our solution.